5-year-old granddaughter, Abigail. Took her on a driving trip to Colorado from Texas, and we're in the big Suburban, and I'm pointing out different stuff, and I'm sort of her teacher. And we're out through in the middle of New Mexico through the Navajo reservation, heading toward the Four Corners area, and I could tell she's getting a little edgy. And finally, this building came in sight, and she's a bit of a drama queen. She was 5, I think, at the time. She goes, "Oh, Papa, finally, civilization," with a B. 5-year-old granddaughter, Abigail. Took her on a driving trip to Colorado from Texas, and we're in the big Suburban, and I'm pointing out different stuff, and I'm sort of her teacher. And we're out through in the middle of New Mexico through the Navajo reservation, heading toward the Four Corners area, and I could tell she's getting a little edgy. And finally, this building came in sight, and she's a bit of a drama queen. She was 5, I think, at the time. She goes, "Oh, Papa, finally, civilization," with a B. and when I saw the sailboat, I went, "Oh, civilization." It was a lot of fun. And then we watched him head off and heading off toward Europe. First time I've ever been in the open Atlantic and got to see another boats. You see them all the time in the high traffic areas, of course, but out here in the middle of the Atlantic, I went, "Oh my gosh, that's not a flying fish. It's actually something we can tell." So I'm starting a new series, 3 lectures. This is called The History of Spaceflight. Today is the early years. Tomorrow will be Man in Space. And then the day before we get to Fort Lauderdale is the race to the moon, including the Russian hardware. So I'm going to build each time on how we won the race to the moon in this period of human space flight by building on certain steps that were laid out that we have to prove. These steps are the early pioneers. And let's start with them. There were basically 3 early dreamers of space travel. And one of them was a Russian, Konstantin Tsiolkovsky. He lived from 1857 to 1935, and he's considered the founding father of Russian rocketry and aerodynamics. Very, very interesting man. He lived in Kaluga, Russia. He was deaf from scarlet fever from a very early age. For those of you who remember, scarlet fever, one of its side effects can be to cause deafness. And he never went to school, and he self-educated himself, and he loved Jules Verne, and he published in 1903 one of the seminal works of the early space travel called The Exploration of Cosmic Space by Means of Reaction Devices. So let me translate that for you. That's actually the English translation from a Russian title that even I can't say. What it means is these reaction devices are rockets, and he developed the mathematics of how do you predict how much velocity and how many stages of a rocket you need to reach orbital velocity, and it laid out the fundamental theories of rocket and spacecraft design in 1903. This is the same time as the Wright brothers for taking the first steps in powered aviation from Kitty Hawk in North Carolina. So he published approximately 90 different works on space travel and related subjects. And down here, for you trivia experts, I hear occasionally there's a space question. Remember the one the other day? How many trivia people do we have? There you go. Trivia is fun. What is the name of the space shuttle that starts with the first letter of the alphabet? It was something like that. And somebody asked me, they caught me in the hall. You know what the good news is? I got the answer right, thankfully. I mean, can you imagine? Retired NASA rocket scientist, chief engineer of space shuttle, who wouldn't know the answer to that? So this equation is an equation that we still use today to predict how much energy or how much velocity each stage would give us, and it's called the change in velocity, delta velocity, is equal to the ISP. That's a measure of how efficient your rocket fuel is, called specific impulse, don't worry about that, times a constant that has to do with gravity, because this would be a different answer lifting off from the moon than lifting off from the Earth. So in this equation, we have a term that represents the gravitational constant of the body you're trying to fly away from, times the natural log of the ratio of mass initial to mass final. In 1903, Tsiolkovsky developed this equation that we still use today. It's sort of like E equals mc squared for physicists, Einstein's equation. This is called the rocket equation that all of us who work in this business still use to this day. Konstantin Tsiolkovsky, famous, very brilliant man, self-educated. The next one came from Germany, and his name was Hermann Oberth. He lived quite a bit longer, to the ripe old age of about 95 years old. He was born in 1894 and died in 1989, and he is considered the father of German rocketry and astronautics. These people never met. There'll be one more, a third one in America, and I'll tell you about. They never met. They did their work independently. They didn't have internet. They didn't travel abroad to see each other. So these three pivotal people. Here's the young Hermann Oberth in 1901, and this is later. He was also fascinated by Jules Verne. His family was from Austria-Hungary, and Jules Verne's novel, From Earth to the Moon, inspired all three of these early rocket pioneers. He built his first model rocket at the age of 14. He independently from Tsiolkovsky derived the concept of, I can't put enough fuel in one rocket in order to reach orbital velocity, but if I stack multiple stages, I can begin this process from liftoff, gaining the first, say, 25% of the energy in the first stage. Its fuel has been expended. I don't need to drag that weight into orbit, so I jettison that stage. Now I start the second stage. I use that same rocket equation, and now I can tell what's the new velocity I can add with the second stage. I burn its fuel, I discard it, and now I take the third stage, and I can now have enough velocity to reach orbital altitude and put a significant payload in orbit. Oberth developed that in the early 1920s. In 1923, he published his famous work By Rocket into Planetary Space. He expanded it in 1929 with additional information. He conducted the first static firings of liquid-fueled rocket engines. We have had solid-fuel rocket engines since the Chinese. My children have used what we call pop bottle rockets. Remember that? They have a little rocket, a slight rocket engine, and they have this long stick to stabilize them, and you'd put them in top of a Coca-Cola bottle, you'd light them and run, and they would go and take off. Of course, we kind of have stopped that process, because if they land on top of your house, that can start your house on fire and fields on fire. But Hermann Oberth and his friends realized that we needed a more powerful rocket engine, and that led to liquid-fueled rocket engines. Interestingly enough, he was assisted at that time in 1929 by the 18-year-old student Wernher von Braun, probably the premier rocket scientist and engineer of all of the world. There's another one called Sergei Korolev in Russia, and we'll talk about them a little bit later. And he described the space-based reflecting telescopes, which became ultimately the Hubble Space Telescope and took many of the pictures. He described electric-powered spaceships, which we're beginning to use now, called ion engines. and he developed the concept of humans will need space suits to work in space because of no atmosphere. Herman Oberth. And then in American, Robert Goddard from 1882 to 1945. We have a NASA center named after Robert Goddard called the Goddard Space Flight Center in Greenbelt, Maryland. He's considered the father of American rocketry. He launched the world's first liquid-fueled rocket engine in 1926 before Oberth and his team began work on liquid rocket engines. He launched 34 rockets. He reached the speeds of almost 1 times the speed of sound, Mach 1, up to 1.6 miles, had 214 patents, including the multi-stage engine, which I mentioned to you, that Herman Oberth and Tsiolkovsky derived independently. And there were some key milestones. A method of reaching extreme altitudes is one of the classic 20th century texts on rocket science. He developed the concept of flight control innovations by putting vanes into the exhaust to be able to give you forces in all 3 directions. Unfortunately, Robert Goddard was vilified by the press as being a bit of a nut job. And Robert Goddard took that very, very personally, and he became highly protective of his work, and he didn't like expanding the knowledge of the American rocket science team as Oberth and Tsiolkovsky did, and therefore America didn't develop these young pioneers like Wernher von Braun and later the Russian Sergei Korolev in these teams of people building rockets with the eventual dream of going into space and into the moon, or onto the moon. Here's his first, Robert Goddard's first liquid rocket engine. What's interesting is that the fuel tank is down here. It pumps its propellant up here into the combustion chamber, and then the nozzle expending the rocket. The reason is this vehicle is much more stable if most of its mass is at the bottom and therefore it's pulling this mass into space. It did not require sophisticated control systems. Every rocket that you see now have the tanks and the mass above it with the rocket engines on the bottom. They are not inherently stable. It's like putting a pencil on its eraser, and any little deviation causes it to fall over. So we have to have gyroscopes that actually sense this motion and swivel the engine to straighten it back up. With this design, it was inherently stable and would climb without those complex systems. He continued his work in Roswell, New Mexico in 1937. His first launch was in Massachusetts. I love this. This came from his diary. Tried rocket at 2:30. It rose 41 feet. It went 184 feet horizontally in 2.5 seconds after the lower half of the rocket nozzle burned out. So they learned from their failures, and they learned what new materials were required, and that's the way of all of our innovations from the Wright brothers on to what you're riding now, 787s across the Atlantic and across the Pacific. Same principle. Then wartime Germany led the way to space. If you've paid any attention to history, it turns out that war is always a significant driver to technological development and technical innovation. Think about the early airplanes of World War I, biplanes, 100, 110 horsepower, slow. They were used as aerial reconnaissance. This is 1918. 20 years later, in 1938, we had high-speed aircraft. The Messerschmitt Bf-109 could fly 400 miles per hour. the British Spitfire, one of the finest fighters in the world, with a Rolls-Royce Merlin engine that had nearly 2,000 horsepower from 100 horsepower in 20 years, from 1918 to 1938 in subs. The same thing is true of rockets. This was the most sophisticated rocket ever developed. Let me tell you some of the things about it. It used alcohol and water as fuel. It used liquid oxygen. They were able to have significant refrigeration. Liquid oxygen is over minus 250 degrees below 0 Fahrenheit. It had a highly sophisticated turbo pump that used hydrogen peroxide to turn its big pumps and its turbines that would pump the fuel, mix it into the combustion chamber, but the first thing it did was took the very cold oxygen and it sent it through the rocket nozzle, which is made of metal, to cool that nozzle. And then it would send the oxidizer into the turbo pumps, then in for combustion. If they had not have done that with these sophisticated engines, just like Robert Goddard's nozzle burned off, this engine would only burn for 10 or 15 seconds and it would melt the nozzle. So they learned to use the liquid propellants to cool these very hot nozzles into the combustion chamber. The other incredible innovations were the Germans invented gyroscopes. One of the things that I must give you the physics lesson, just in case this comes up in trivia, is the gyroscope is a spinning top, and it wants to stay in the same orientation because of its spin, and any force that I put on this gyroscope will cause it to tilt over. If I measure the rate of that tilting and the angle of that tilting, I can gather information about where this rocket is going and send information to these veins down in the exhaust and tell them if the rocket's starting to tilt too much to the right, move the thrust in these veins back to the left and put it back upright and then straighten the veins out. And the way that we do that is we have one axis for pitch of the boat, we have, or the ship or the rocket. We have a second one at right angles, a gyroscope, that now tells me yaw, left and right, and a third one at right angles, making these three orthogonal, meaning 90 degrees apart gyroscopes. Each one tells the third axis is roll. So I have pitch, yaw, roll information in this package. Each one is sending the appropriate signals down here to control the rocket. The Germans had that and developed it in 1942, the first successful flight from Peenemünde on the North Sea, and this was incredibly sophisticated. 46 feet high, it weighed 28,000 pounds. It had a thrust of 56,000 pounds. It could carry over a 2,000 pound payload, 200 miles at a max speed of 3.5 times the speed of sound, and reached 60 miles. After its engine burned out, it would continue climbing up to 60 miles, and then it would come back to the Earth just like an artillery shell, landing on wherever they targeted. Antwerp, London. London had many of these in 1944. Over 3,000 of these weapons fell on London and Antwerp in 1944. So let's go back just to give you a hint of how incredibly advanced this weapon was. The payload, 2,200 pounds, that's about roughly equivalent to the 16-inch main gun battery from the USS Missouri or the USS New Jersey. It looked like a Volkswagen going through the air when they launched that thing. And they could launch that 16-inch gun used on D-Day and throughout the Pacific about 28 miles. So this rocket takes the payload of the largest naval gun on the planet during the time and sent it about 15 times further than the USS New Jersey or the Missouri or the Yamamoto. Very, very sophisticated. Every rocket right now, this is the great-grandfather of all rockets anywhere on the planet Earth. It was actually discovered that Peenemünde was the test site because the British had some information that there was testing of a new weapon going on, and they sent unarmed Spitfires. The reason the Spitfires were unarmed is so they could fly faster than any of the fighter airplanes and evade them. So they had no machine guns on them. They had very sophisticated cameras, very risky mission over wartime Germany, and they discovered using three-dimensional photography, this is the launch site with a V2. Here's a V2 sitting on the side right here, and this is the launch pad from which they assembled them and put them together, rolled them out, brought them here, fueled them. Where did they build these rockets? In a cave in Dora Mittelbau concentration camp is where they moved the production of these rockets after extensive 2 different British bombing raids. Once they discovered that Peenemünde was the manufacturing and test site, they destroyed it. They destroyed a lot of the German scientists, actually. The majority survived, but the Germans moved the production underground in 1943 and 1944. The Germans also built a support structure called the Mueller wagon, but really, my good German friends, I have to remember to pronounce W's as V's, right? So this is the Mueller wagon, not the Mueller wagon launcher. It carried it horizontally with hydraulics before it was fueled. It's much lighter at that time, would erect it into the vertical position. It had its own circular launcher. It had a separate vehicle that carried the fuel, alcohol, and water, carried the support structure, the power and the batteries, and also the liquid oxygen. They could fuel it. This is the first mobile intermediate range ballistic missile in the 1940s, early 1940s. Its first test flight, 1942, was not successful, but they kept working on it, improving the design, and it became very, very successful. This I find to be a very interesting picture. In 1943, they have flown successfully the V2. Hitler knows that it can be used as a weapon. Its acronym V as in Victor stands for Vengeance Weapon. The V1 was the horizontal flying bomb, and the Brits knew that when you heard the put, 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 put of the engine, when that sound stopped, you went underground and you prayed a lot, because that meant the V1 was going to fall and its bomb would explode. The V2, very different. See, the V1 was subsonic. You could hear it coming. The V2, before it hit the ground, it's going 3.5 times the speed of sound, and just like a bullet, you never hear the one that hits you. You only hear the one that misses you. So the V2 was a very, very scary weapon. You never heard it until it hit and exploded. No warning. This group of VIPs went to Peenemünde in 1943, and I want to show you some of the key people. Dr. Walter Thiel, he was a propulsion design expert and was highly important in the development of the very sophisticated V2 engine. Dr. Thiel later came to the United States after World War II with von Braun and his team. Here is, right here is a famous German called Count von Stauffenberg. Anybody remember the importance at the Wolf's Lair in 1944 of von Stauffenberg? Yes, sir, Alan. Exactly right, exactly right. Von Stauffenberg was the insider as part of the plot to kill Hitler that carried the suitcase with the bomb into the wolf's lair, and he set it under a table where Hitler and the team would be. Unfortunately, one of the other officers, after von Stauffenberg left, moved this briefcase right next to a heavy, heavy oak structure that supported this huge conference table. Hitler happened to be on the other side of that structure and survived the explosion. It killed many of the officers, but what an interesting, and he was part of this team. Right next to him is Hermann Oberth. Here is a great, interesting guy called Grand Admiral Karl Donitz in the naval greatcoat, so he was a Navy officer. General Heinz Brandt. Right here is Walter Dornenberger, who led this effort for the Nazis in World War II. And right here is an interesting person you might recognize. Any guesses where my circle is there? That's von Braun himself. That is Werner von Braun at the time. Brilliant, brilliant man. His real name, Werner Magnus Maximilian Fuhrer von Braun. Can you imagine that in your spelling test? 1912 to 1977. He was born in Germany in 1912. He was from a very aristocratic family. His father served as a minister of agriculture in the Weimar Republic. His mother could trace her ancestry to both parents' descendants. She was a descendant of Philip III of France and Robert III of Scotland and Valdemar I of Denmark. And I see I have a typo there I need to fix. And Edward III. So this was a very aristocratic family. He was an accomplished musician. He played the cello and the piano. He loved playing Beethoven and Bach. He developed a very early interest in astronomy and rocket propulsion. He attended the University of Berlin. He got his PhD there. He met two very, very important people, Willy Ley and Hermann Oberth himself, during the liquid-fueled rocket tests of 1929-1930. And then under Walter Dornenberger in the previous picture, he served as their technical director at Peenemünde and really was the leader of this large team that successfully developed. The Germans called it early the A4, but then Hitler changed its name to Vengeance V2. Most of the German scientists came to the United States, and I love some of this. This is after D-Day, Germany's falling, June the 20th, 1945. Von Braun and about 1,000 other of the German test engineers and their engineering team at Peenemünde and their families came from East Germany. Peenemünde was in what was called Prussia, up on the North Sea, north and east of Berlin. And then after the war, Germany was divided into East Germany, with Berlin and the three zones, Russian zone, American, and British, and then West Germany. And they left that eastern area and came to the western zone just ahead of the advancing Red Army. They would be absolutely pivotal in the development of the U.S. and the Russian rockets. I love this one. One of their rocket engineers in 1945 said, "We despise the French. We are mortally afraid of the Soviets. We do not believe the British can afford us, so that leaves the Americans." And there we go. The Soviets found the V-2 underground production facilities, but we had already removed most of the tooling, many of the finished rockets. We sent a bunch of them to the West Coast near El Paso, Fort Bliss, and we shipped them to the West. Some of the top experts in their flight control system accepted the Russian promise to stay and work in Germany. They restarted the V-2 production for the Russians in their controlled area, but then Stalin secretly ordered that all 500 of these engineers and their families and 7,000 workers were deported and kept in Russia in October 1946. And Sergei Korolev, that we'll talk about in a minute, was one that Gottrup, one of the Russian designers, worked, and they had propulsion specialists. This propulsion team gave the Russians the most powerful rocket engines very early. That'll become important in tomorrow's lecture. Sergei Korolev, right now, his identity was kept a secret. He guided the R-7, or the Russian rocket I showed you that they still use today, a greatly extended and approved one that was the first ICBM, intercontinental ballistic missile. It launched Sputnik in 1957 and launched Yuri Gagarin, the first human in space, in 1961. He died from a botched stomach cancer operation on the table in 1966, and that seriously affected the Russian team and their race to the moon. He was a brilliant designer. What's interesting about him is that both he and his colleague Valentin Glushko were thrown into the Gulag and prison under Stalin in 1938, but they were so valuable that they were released from prison and then allowed to work in the Russian rocket industry. Mr. Stalin was a very sick and disturbed man in the 1930s and probably long before that. Glushko led the design of their huge rocket engines, including the Buran space plane that I showed you a picture of the other day that had as powerful a booster as the Saturn V. Here's Korolev's first rocket. This is a rocket launched during a test, but this is the rocket that launched Sputnik to orbit in 1957, and then just 4 years later, a little under that, 3.5, Yuri Gagarin into space. Over 500 of this design were produced. If you remember, these are the 4 booster rockets on the side that use this cluster of engines, 4 nozzles with 1 combustion chamber, and then the same 4 engines in the center core. What you'll notice different about this than the modern Soyuz is the second and third stages are much longer, and this core stage is roughly about the same, but this same proven design is still in use today on the Soyuz rocket. Very, very reliable rocket. Sputnik 1, here it is, basically went up and went beep, 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 beep. It was essentially a fancy radio in orbit. These are the antennas for the radio. And what is surprising to me is how much and how the West reacted to this first satellite in orbit. We'll talk about that in a minute. Notice now from this earlier picture right here that would launch Sputnik, notice this area, the second stage, has been extended, more fuel in the third stage, and here's the Vostok 1 capsule. This is actually a picture taken from the museum. This capsule exists in the museum in Moscow. April the 12th, 1961. Gagarin sits inside. We normally have to shroud the spacecraft to protect it from the high aerodynamic forces as the rocket climbs up out of the air, and then after it gets through 2/3 of the air, you have very high aerodynamic heating, friction, because I'm accelerating, going faster and faster. So this shroud is intended to protect it against aerodynamic pressure and heating, but you can see the Vostok capsule right there where my arrow is. Instead of having sophisticated vent valves that we now use and the Russians use also, they've kept their design very simple. They just had a big hole right here on the side, and so the atmosphere could go out as it climbed up. If you don't get rid of that atmosphere, it's like a balloon and can blow this shroud off, and you would lose the payload. The other interesting thing is only this part landed. Here's the entry capsule. Notice the re-entry damage of the ablative heat-resistant material. Ablation is a term that we use where you design the re-entry to be about this thick on the bottom, and the material erodes or ablates away, and the purpose of that is, as it goes away, it takes this extreme excessive heat away from the spacecraft. So what started out at reentry about 4 inches thick, at the end of reentry is about 1 inch thick. It's a planned way to remove the heat. We can use that today. The space shuttle was the first one to use a system that did not use ablation, and therefore its thermal protection system was reusable. None of these spacecraft ever flew more than once, nor did any American spacecraft in the Mercury, Gemini, or Apollo capsules ever fly again. The last final thing I would say about this big hatch was blown off. They had not perfected the landing system that could slow it down enough for the astronaut to survive the landing on Earth. So at around 5,000 feet, this hatch is blown off. Yuri Gagarin is in an ejection seat, and he is ejected out and parachutes down to the Earth, just like you would leave a fighter plane that had a problem with your ejection seat. Russians kept that secret for years, by the way. America moved the rocket scientists to White Sands in New Mexico, and they developed what's called the WAC Corporal. So here's the V2 core that we put a second stage above it. The V2 was one stage only, could never go into orbit, could go up to 60 miles up, but it couldn't go fast enough to ever reach orbit. That's why we started putting new stages. This one reached 244 miles, 5 times the speed of sound. It was a record until 1957, when Sputnik's rocket actually put a spacecraft in orbit. We did our testing out near Fort Bliss and to the west of it. How did the Americans bring the German scientists? Because the interesting thing is, President Truman had an anti-Nazi exclusion. He said, we are not going to allow to immigrate to the United States any Nazis. And that would have prevented most of the German rocket scientists from immigrating to America. So the organization, this group, OSS, is the precursor or the father of the CIA. They brought the rocket scientists to Fort Bliss in January 1946. Then they expunged or took away or burned or erased the public records of their membership, created false employment political biographies for these scientists. It says, to circumvent President Truman's anti-Nazi exclusion. I'm quite confident that the administration knew that these rocket scientists were coming to the United States, and why they were coming, because they realized this was critical to any future military development. And this is the group itself, and here's von Braun right here. And this group of people began the U.S. space program in 1946. After Sputnik, America's first civilian satellite, fails on live TV in November of 1957. It was called Vanguard 1. The engine started up. There was some major failure in the engine and propellant. It lost thrust. The vehicle lifted off about 4 or 5 feet and then comes back and falls onto the pad. And this is a picture of the satellite intended to go into orbit as it ignominiously breaks off this giant rocket. The rocket collapses on itself in a huge explosion. The thing that really helped America was von Braun and his team. Even though they did not win the contract to try the first U.S. orbital launch, the Navy won it. The Army team kept going, and they quickly put together what's called the Jupiter C, which is an extended V2, same engine and design, more fuel, and they were able to put Explorer 1 into orbit in January 31st, 1958. So this is about 3 months after Sputnik. And here's von Braun and his team. James Van Allen was a physicist. One of the payloads, and this is the payload, Explorer 1, one of its instruments discovered the radiation belts. There are two of them, major radiation belts, much higher than the space station's orbit, thankfully, so that we don't fly through them all the time, that result from the Earth's magnetic field capturing these highly energetic particles from the solar wind. It would be damaging to our bodies, and they are in fact still named the Van Allen belts, and we avoid flying through them or staying in them a long time. Mr. Pickering was the head of the Jet Propulsion Laboratory in California. This is the Jupiter C. It has the same diameter but much longer tanks. Here's the payload on the top. It was spinning for stabilization, and that's the last stage of the rocket that put this payload into orbit. Later, von Braun, and I remember this well, 1955, by this time I'm 8 or 9 years old, and I'm already a budding rocket scientist. I didn't realize it until much, much later. But I loved this TV series called Man in Space, and von Braun, excuse me, was a principal advisor to Walt Disney and did a lot of this very, very early work. I hope you can get this on Netflix or something. It was a remarkable series. I remember it to this day. Then von Braun and the Huntsville team continued to expand the V2, making it longer, more fuel, some more powerful engines, and this is the Redstone that now sends Alan Shepard on into space on May the 5th, 1961, but this rocket was still not powerful to send the Mercury capsule, here's the escape system right here, into orbit, but could only fly a suborbital trajectory that would put Alan Shepard and Gus Grissom downrange, and they would land in the Atlantic Ocean several hundred miles east of the Kennedy Space Center. This was our first attempt. Notice that the Russians went immediately to Earth orbit, did not do this. Their rockets were more powerful, more capable, and they had a very, very significant lead. But both Alan Shepard and Gus Grissom in 1961 rode this as the first Americans in space. We still had not orbited the Earth. We needed a more powerful rocket, and that is the Atlas intercontinental ballistic missile, and it became operational October 1959. Convair Group out in San Diego built this rocket. 4 of the 8 first test flights failed. Because this was very hard to do stuff. And now this ICBM was 85 feet tall, 10 feet in diameter, had a 9,000-mile range. We now have a rocket that's powerful enough to put a capsule on top of it, and that is how we launched John Glenn, the first American to orbit the Earth on top of the Atlas V. Interestingly enough, all 7 of the original astronauts went to Florida in the early testing here, 58, 59, 1960, before we put humans on, and they watched several of these tests blow up in front of them. What I admire is they trusted the team to figure this out and get it right before the one that they rode on blew up. So that's some pretty brave guys. Here's John Herschel Glenn. February 1962, notice almost a full year after Yuri Gagarin had orbited the Earth, and this is the actual picture of, for 3 orbits, John Glenn in his Friendship 7, the 7 meaning the 7 initial astronauts, Friendship meaning we do this on live TV. There was never a Russian launch on live TV, and rarely did they ever release any photographs except internally to their own people to prove their own propaganda that the Russian system of communism was better than the American system of capitalism. We chose to do everything, even our failures, on live television. I find that an interesting contrast. The Atlas vehicles are still flying today. This is our most powerful booster called the Atlas V, but it started from this one right here, with the same evolution as the Soyuz rocket, has a very similar path from 1957, and I need to update this. We're still using it today in 2015. The Russian Soyuz rocket had a similar evolution. Notice that the vehicle gets longer, wider, taller, more powerful engines, always with the objective of carrying heavier payloads into space. Again, the Russian Soyuz, note now how much longer the first stage is. The boosters are about the same. Same design, but more powerful engines, and a much bigger first stage, second stage, and this is the vehicle still used today, right now, to carry any humans to the International Space Station until America goes back to, and we are in work doing that, developing the shuttle replacement that we hope to fly in 3 or 4 years. And of course, the Soyuz rolling out horizontally, and you can see all of these engines. This is the same pad that Gagarin launched from in 1961. Of course, its booms and arms are held up. They're much longer because this vehicle is more powerful, and this is what they actually send into space, the Soyuz spacecraft. Von Braun, with JFK at Redstone Arsenal, he built, of course, the Saturn V, which is our moon rocket, the largest rocket ever developed by any humans. This was even more powerful than a space shuttle. And here's von Braun with his mighty F5 engines. 5 of these engines had 1.5 million pounds of thrust each. That's 15 747 engines, and they produced 7.5 million pounds at liftoff to send this vehicle into orbit. An unbelievable achievement. So there we go with the early years. And tomorrow, we're going to now start talking about humans in space, Mercury and Soyuz and etc. And then the third day will be the race to the moon, some unique photos of Russian hardware that most people never get to see. Have time for just a couple questions if you have any. Anybody over here? Yes, sir. Is Sputnik 1 in orbit? Very good question. No, it's not. We had to put a spacecraft at higher altitudes. Sputnik 1 went into orbit at less than 100 miles above the Earth. Space station is 250 miles above the Earth, 220 nautical. And the further away from Earth you go, the less atmosphere. Even though there's almost no atmosphere, Sputnik 1 stayed up for only several months before its orbit slowly decayed, and then it re-entered the atmosphere and burned up. Good question. Anybody else? Have a great afternoon. Thanks for coming. Enjoyed it, and we'll see you tomorrow.